So let's start with our fundamental quantities. And we have two. Get a nice underline of that. So the first is going to be stress. And stress is going to be the axial force divided by the cross-sectional area. And we're going to give that a name sigma, and that's going to be equal to N, which is a force, divided by A, which is the area. And the second fundamental quantity that we're going to need is going to be strain. And strain is going to be the change in length divided by the original length. Okay, and we're going to call strain epsilon, and we're going to say that that's equal to our deformation, or our change in length, delta, little delta, divided by the original length, which we're going to say is L0. Okay, and so there's a couple of things here. The first thing, what is stress, really? Stress is just the intensity of the force that is experienced by a material. And you can see that for a given force, the larger the area, the lower the intensity. Now for strain, there's actually two things I wanted to point out. The first is this one. Now we're going to define strain in this class in terms of the engineering strain, and that means that we're going to be needing to use the original length of the material. There are other ways to calculate strains, and we'll talk a little bit about those briefly when we talk about constitutive laws. And what is strain? Strain is the intensity of the deformation that is experienced by a material. And so now we have a measure of the deformation, we have a measure of the force, and we have the two things that we're going to need to really talk about when we're looking at these one-dimensional systems. And just to talk a little bit about units here, so the units for stress. So stress has units of force per area. And in our US system, that would be something like 1,000 pounds per square inch, which is going to be equal to 1,000 psi. And because civil engineers often work with really big units, we've given 1,000 psi a special name, so we call that 1 ksi. So 1 kilo psi. And that unit you'll see in some of the homeworks. So in the metric system, used everywhere else, we might call this we might use newtons per meter squared. So 1,000 newtons per meter squared, and that would be equal to 1,000 pascals. And you can use all of the prefixes in the metric system. So now we go up, that would be 1 kilopascal. The next one, fundamental quantity here is strain. So you can see that strain is a deformation divided by a length. And so strain ends up being dimensionless. But to make sure that we are all clear on what we're talking about, a lot of times we will include the units. So we would do so in a length per length. And so we would have a unit that would look something like this. So 0.001 inches per inch. And that is going to be equal to 0.001 millimeters per millimeter. And you could use it in terms of percent. So we'd have 0.1% elongation, perhaps. And the other unit we might use, and you might see sometimes, is that would also be equal to 1,000 microstrain. So that micro means that this is 1,000 times 10 to the negative 6th strain.